Welcome to the next session of the subject Engineering Maths Chapter 2 Differential Equations. We were in the discussion of classroom workbook. Let us start the session with question number 26. Just open your classroom workbook. Let us start the session with question number 26. What it is, the initial value problem, dy by dx equal to 3x minus 2y divided by x with y of minus 5 equal to 3 is, options are given in terms of x. So when the boundary condition is given and particular solutions are given, directly verify options. See, what is first option? X cube minus 200. The first option is x cube minus 200 divided by x square. So what is mean by this? When x equal to minus 5, y equal to 3. So all these are y values. Replace x by minus 5, we get minus 125 divided by 200 divided by minus 5 whole square 25. So this is nothing but minus 325 divided by 25. This is a number negative, but you must get y value positive. Therefore, option A does not satisfy given boundary condition. So option A is wrong answer. Now let us verify option B. It is x cube plus 50 divided by x square. So replace x by minus 5. This gives minus 125 plus 50 divided by minus 5 whole square. This is 25. So therefore in this case, when x is minus 5, minus 125 plus 50. So it is minus 75 by 25. This is again negative, but y must be plus 3. So eliminate option C. Now look at option C. Here option C is x cube minus 50 divided by x square. Replace x by minus 5. This is minus 125 minus 50 divided by minus 5 whole square 25. This is again negative. So y equal to plus 3, but here it is negative. So option C does not satisfy given boundary condition. So interestingly, the first three options, option A, B and C, do not satisfy given boundary conditions. So ultimately D is right answer. So you can write directly like this. Options A, B and C. Options A, B and C do not satisfy the given boundary condition. Hence D is right answer. I repeat once again. Options A, comma B and C do not satisfy given boundary condition. Therefore D is right answer. This is one way, because directly we are getting option A is eliminated, B is eliminated, C is eliminated. So D is right answer. Now we can solve this question in another way also. In all options, variable part is same. In the numerator we have x cube, in the denominator x square, but constants are different. Therefore directly from all the options we can say that the general solution is y equal to x cube plus c divided by x square. This is the general solution from all options. Now let us try to find c value by using this boundary condition. Y value 3, x value minus 5. So 3 equal to minus 5 whole cube minus 125 plus c divided by minus 5 whole square. This is 25. So 75 equal to minus 125 plus c. So c value equal to plus 200. Therefore option D is right answer. Right? Not this. Now let us move to next number, question number 27. The general solution of dy by dx plus tan y into tan x equal to cos x into secant y is, options are given. Now let us try to solve this equation. They were asking directly general solution of this equation. No boundary condition is given, so we need to find general solution. Let us see. You cannot handle this by separation of variables. When you take tan by tan x to the right side, so the equation becomes like this: dy by dx equal to cos x into secant y minus tan x into tan y. Now between functions of x and functions of y there is a minus symbol, so variable separable method is not possible. That is, method 1 is not possible. For method 2, what is required is, it is in the form mdx plus ndy equal to 0. That is, dy by dx equal to minus m by n. So this must be a homogeneous function of degree 0. But when you have trigonometric functions, homogeneous is not possible. So method 2 also not possible. Method 3 means a substitution method, even that is also not possible. So therefore, let us try to solve this equation in the different way. Here I am going to apply linear property of differential equations, that is the linear equation. See, to get linear equation, my equation must be in the form dy by dx plus py equal to q. Here p comma q are functions of independent variable x only. So here if you assume that this as q of x, here I have secant by extra. So therefore let us try to multiply this equation with cos y. Therefore hence in that case secant y can be eliminated. So therefore let us multiply this equation with cos y. Cos y into dy by dx, cos y into sin tan y, this is sin y into tan x equal to cos x. Now therefore even if you want to get linear equation, here power of y must be 1, but here sin y is there. So take sin y equal to some new variable z. Therefore differentiate this, we get cos y into dy by dx equal to dz by dx. Because to get linear equation, I must have the structure dy by dx plus py equal to q. Here p comma q are either constants or functions of x. But in this case, we have q of x, but extra we have a term in terms of y. That should not be there. Therefore, to eliminate secant y, multiply this equation with cos y, so that the equation will be reduced to this form. So right side, I have eliminated functions of y. But here I must have power of y is 1, it is a single variable. But here I have sin y. So take sin y equal to z, differentiate this, I get this. So in place of cos y into dy by dx, we can write dz by dx. Therefore this equation is dz by dx plus tan x into z equal to cos x. Now this is p value, function of x, this is q value. So therefore this is an equation which is linear in z. In place of y we have z. dz by dx plus pz equal to q. So therefore this is linear in equation in z. Here I call it as equation 1. So here equation 1 is linear in z. Therefore what is the general solution? Y into I of equal to integral q into I of dx plus c. But before finding this general solution, let me find what is IF. This is e power integral p dx. So e power integral, what is p? Here p is nothing but tan x. So e power integral tan x dx. So integral tan x is log secant x. So this e and log can be cancelled. So this will be secant x. Right? Therefore, let us get back to this general solution. Y into I of is secant x equal to, what is q? U is this. See, actually this is a linear equation in z. So here y has to be replaced with z. So z into I of equal to this. Now here this is z into secant x equal to, here what is q? Q is nothing but this cos x. So cos x into secant x. that is integral 1 dx, that is x plus c. But what is z? Z equal to this is sin y. Therefore, sin y equal to x plus c into cos x. 1 by secant x is cos x. Therefore, this is the general solution of this particular equation. What it is? Sin y equal to x plus c into cos x. So, therefore, option B is right answer. Option B is right answer. Note this. To question number 28. Question number 28. A curve passes through the point x equal to 1, comma y equal to 0 and satisfies the differential equation dy by dx equal to x square plus y square divided by 2y plus y by x. The equation that describes the curve is, it's a first order first degree differential equation. So boundary condition is given. They were asking the equation that describes the curve is, indirectly they were asking particular solution of this equation. So this is my first order first degree differential equation. Boundary condition is given. They were asking particular solution. So all particular solutions are given as options. Let us try to verify options. So x equal to 1, y equal to 0. In option 1, when you replace y value 0, x value 1, it satisfies. Because option A is this. So it is log of 1 plus y square divided by x square equal to x minus 1. This is option number A. So replace y by 0, x by 1, you will get log 1. 0. Log 1 is 0, 1 minus 1, 0. So it satisfies given boundary condition. It may be right answer, may not be. So don't confirm this and don't eliminate, hold it. Next, option B. It is half into ln of 1 plus y square by x square equal to x minus 1. The same case, when you replace y value 0, x value 1, so half into log 1. Log 1 is 0, 0 equal to 0. It satisfies. Don't confirm, don't eliminate. Option C. It is log of or ln of, log means log with base e. So we can write simply ln or log. No issues even if you write log. So log of 1 plus y by x equal to x minus 1. Here also when you replace y value is 0, x value 1, log 1 is 0, that equals 0 equals 0. Don't confirm, don't eliminate. The same case with option D also. So what is option D? Half into ln of 1 plus y by x equal to x minus 1. Here also when you supply this boundary condition, we get 0 equal to 0. So what happened in this case is, all options are satisfying this boundary condition. So therefore, we cannot eliminate even a single option. So we need to work out this problem completely. Let us solve this. Now here the equation is this. Let us try to manipulate this equation like this. Here dy by dx equal to, here this is x square by 2y plus y by 2 plus y by x. So this implies dy by dx plus this is minus y by 2 minus y by x equal to x square divided by 2y. So this implies cross multiply this equation, we get 2y dy by dx plus when you multiply this equation with this, we get actually minus y, but therefore this is multiply this with 2y, we get this as this is minus y square and this is minus y square divided by x, minus y square by x equal to x square. So this implies 2y into dy by dx plus minus 1 by x into y square equal to x square. This is my equation. Just we have manipulated this equation and multiplied this equation with 2y. When you multiply this equation with 2y, this becomes 2y dy by dx plus minus y square by x in equal to x square. Therefore, here I have q of x as x square. It seems to be linear equation in y, but not completely. But here this is p, it resembles, I feel that this is p, but here the coefficient of dy by dx must be 1, but in place of 1 I have 2y, but in place of single variable y we have y square. Therefore here what I do is I will take y square equal to some new variable z. Therefore 2y into dy by dx equal to dz by dx. Therefore in place of this 2y into dy by dx I can write dz by dx. So hence this equation becomes dz by dx plus minus 1 by x into this z equal to x square. So therefore this is p and this is q. So it is linear in z. So what is integrating factor? E power integral p dx. So this is e power integral minus 1 by x into dx. So therefore this is e power minus x minus log x. So therefore this is e power minus x into e power log of x inverse. So therefore this is e power minus x divided by x. Therefore this is the integrating factor of this equation, e power minus x divided by x. Therefore the general solution is z into if. If is this, e power minus x by x equal to integral q. Q means what? Q is this x square. So therefore in this case q is x square. So therefore in this case what I do is, let me verify this. Here p is minus 1 by x. So if is e power integral p dx. So therefore this is e power minus x into e power minus log x, e power minus x by x. Yes, it's a right calculation. Therefore z into if equal to integral q into q is nothing but what? This is x square into e power minus x by x dx plus c. So therefore this implies z into e power minus x by x equal to this is x into e power minus x dx plus c. So therefore this implies z into e power minus x by x equal to, now let us try to solve this by integration both sides, I mean integrating by parts. So in this case what I do is x into e power minus x dx minus derivative of x is 1 into e power minus x dx whole dx. So therefore this is z into e power minus x by x equal to, this is x into e power minus x, this is e power minus x by x plus e power minus x, again this is e power minus x by minus 1 plus, again this is e power minus x. So therefore this implies z into e power minus x by x equal to, this is x minus 1 into e power minus x. So therefore this implies z equal to e power minus x will be cancelled. Of course we forgot to write this constant c. This is constant c and in this case we get constant c. So therefore in this case z into e power minus x equal to x into x minus 1 into e power minus x plus cx. Now this is my general solution. So first note these points. We continue finding C value after a few minutes. Here we forgot to write minus symbol. So integral e power minus x is minus e power minus x. This is minus x into e power integral minus x dx minus derivative of x is 1. Integral e power minus x is minus e power minus x, minus minus plus becomes again integral e power minus x is this. So therefore this becomes minus of x minus 1. This is minus of x minus 1, or simply we can write minus of x plus 1 dx. So therefore this is z into e power minus x equal to minus of x into x plus 1. Now let us try to work out this. So therefore here what is my z? Z is y square. So y square into e power minus x equal to minus x into x plus 1 into e power minus x plus c. Now what is my boundary condition? X value 1, y value 0. So y value is 0, x value is 1. So this becomes minus 2 into e power minus 1 plus c. So c equal to 2 times e power minus 1. Therefore here y square into e power minus x equal to, this is minus x into x plus 1 into e power minus x plus 2 times e power minus 1. So this implies y square in y square plus x into x plus 1 into e power minus x equal to 2 times e power minus 1. Therefore this implies y square plus x square plus x divided by 2 equal to e power x minus 1. Now when you apply log on both sides, this becomes x minus 1 equal to half into log of y square plus, this is half 1 by 2 into e power x minus 1 is equal to 1 by log of this 1 by 2 into y square plus x square plus x. So therefore it is x minus 1 equal to log of half into y square plus x square plus x. Now let us start question number 28. A curve passes through the point x equal to 1 comma y equal to 0. So here it satisfies the differential equation dy by dx equal to x square plus y square divided by 2y plus y by x. X square plus y square divided by 2y plus y by x. The equation that describes this curve is, options are given, all options are in terms of x, that means they gave us particular solutions. Interestingly, all options satisfy given boundary condition. Try to replace boundary condition x value 1 and y value 0. So every option satisfies the given boundary condition. So in that case, we need to solve this question completely. Let us see. Here we cannot solve this equation by separation of variables. Even this is not a homogeneous function. So it is a homogeneous function but degree is 1. If it is a homogeneous function of degree 0, we can take y equal to vx. That means we can solve this equation by method number 2. But this is a homogeneous function of degree 1 in this case, but it's a homogeneous function of degree 0. Therefore, the total function is not a homogeneous function of degree 0. So let us manipulate this equation like this. So here dy by dx equal to x square by 2y plus this is y by 2 plus y by x. So for this implies dy by dx equal to x square by 2y plus half plus 1 by x into y. So therefore this implies dy by dx plus minus 1 by 2 minus 1 by x into y equal to x square divided by 2y. Now to get this as linear equation in y, what we need is, it must be in the form dy by dx plus py equal to q. It must be in the form dy by dx plus py equal to q. So I can expect this value p, it is a function of x. But here I can feel it as q, but here I have extra 2y. So multiply this equation with 2y on both sides. So this implies 2y into dy by dx plus multiply with 2, you will get minus 1 minus 2 by x into y square equal to x square. Now this will be acting as, for example, p, I hope so, and this will be expecting as q. Let us see. But if it is p, it is a function of x. If it is q, this is a function of x. But here I must have y only, but it is y square. So let y square equal to z. Let y square equal to z. This implies 2y into dy by dx equal to dz by dx. So in place of 2y into dy by dx, we can write dz by dx. Therefore, this can be written as dz by dx plus minus 1 minus 2 by x into this y square is z equal to x square. Therefore, this equation is in the form dz by dx plus pz equal to q. Here what is my p? Minus 1 minus 2 by x and q equal to x square. So here I call it as this as equation 1. Therefore, here equation 1 is linear in z. Linear in z. dz by dx plus pz equal to q. So p is minus 1 minus 2 by x. It is a function of x. It is a function of x. Linear in z. What is my integrating factor? E power integral p dx. So therefore this is e power integral minus 1 minus 2 by x into dx. So therefore this is e power minus x into e power minus 2 log x. So therefore this is e power minus x divided by x square. So this is my an integrating factor. So what it is? E power minus x divided by x square. Therefore the general solution is z into I of equal to integral q into I of dx plus c. What is z? Z value is, this is y square. So y square into integrating factor is e power minus x by x square equal to, what is q? Q value is x square. Q multiply q with this, I will get e power minus x dx plus c. So therefore this is y square into e power minus x by x square equal to, this is minus e power minus x plus c. So therefore, this implies y square into e power minus x equal to minus x square into e power minus x plus cx square. So group these values, e power minus x into x square plus y square equal to c into x square. Now what is my boundary condition? The boundary condition is x value 1, y value 0. In fact, this is the general solution. So apply this boundary condition, x value 1, y value 0. When x is 1, this is e power minus 1, y is 0. So therefore c equal to e inverse. Therefore e power minus x into x square plus y square equal to c is e power minus 1 into x square. Therefore rearrange all the terms. We get 1 plus y square by x square equal to e power x minus 1. Now apply logarithm on both sides. That means natural logarithm. Natural logarithm means log with base c. So this is log of 1 plus y square by x square equal to ln of this, we will get x minus 1. So therefore the final particular solution is ln of 1 plus y square by x square equal to x minus 1. ln of 1 plus y square by x square equal to x minus 1. So option A is the right answer. Option A is right answer. See, it requires lot of evaluation, but finally it is reduced to linear equation in the variable z. Okay. Only thing is rearrange all the terms so that the equation will be reduced to linear in z and apply the procedure as per method number 5. So finally you get the general solution and then apply boundary condition. The particular solution will be like this. Okay. Blind calculation, right? So only thing is you need to identify that this equation can be reduced to linear equation. Next we move to question number 29. Question number 29. The question is this. The solution of x into dy by dx the solution of x into dy by dx equal to x square plus 3y with a boundary condition y of 1 equal to 2 is several options are given. Now let us try to solve this equation just by verifying options. Boundary condition is y of 1 equal to 2. What is my option A? In option A, it is y value is x cube plus 3x square. So when you replace x by 1, it is giving 4, but y value must be 2. All these are y values. When you replace x by 1, we are getting 4, but you must get 2. So option A does not satisfy this condition. Eliminate this. Option B, it is x square plus 3x cube. Here also when you replace x by 1, it is giving 4. We are not getting 2. Eliminate option B. Now come to option C. It is a minus x square plus 3x cube. When you replace x by 1, we are getting 2. It may be correct answer, may not be, hold it. Don't confirm, don't eliminate. Come to option D. It is a minus x square minus 3x cube. When you replace x by 1, we are getting minus 4. It does not satisfy given boundary condition. So we are very fortunate in this case because option A, B and D do not satisfy the given boundary condition. First option is giving 4. Second option is giving 4. Last option is giving minus 4. So option A, B and D do not satisfy given boundary condition. So A, B and D can be eliminated. So option C is right answer. You note that point. Only option C satisfies the given boundary condition. Only option C satisfies the given boundary condition. Hence C is a right option. Only option C satisfies the given boundary condition. Hence option C is right option, right answer. Option C is right answer. Now let us move to question number 30. Question number 30. what it is? The solution of dy by dx plus y cot x, dy by dx plus y cot x equal to cosecant x is options are given. Now they ask us directly find its solution because the answer is given in terms of general constant c. Now you can see this is p, function of x, this is q, function of q. So this equation is a linear equation in y. So here p equal to cot x and q equal to cosecant x. Here integrating factor if equal to e power integral p dx. So this is e power integral cot x dx. Integral cot is log sin x. So e and log will be cancelled. So the result is sin x. Now integrating factor is sin x. General solution is y into if. If is sin x equal to integral q into if. Integral cosecant into sin is 1 dx. So integral dx plus c. So therefore y into sin x equal to x plus c. Now take this sin x to the RHS. So this becomes y equal to x plus c into this as cosecant x. Therefore in this case the solution is y equal to x plus c into cosecant x. So option B is right answer. It is directly a linear equation in y. So you get the solution. Finally you get option B. Note this point. Now with this we have finished classroom workbook from question number 1 to 30. That means all 30 questions are based on method 1, method 2, 3, 4, 5. Right. Now let us discuss few definitions which are very useful for next methods to solve first order and first degree differential equations. The definition is Bernoulli's equation in y. Bernoulli's equation in y. Earlier we have seen linear equations in y. Now actually this Bernoulli's equation in y is an extension of linear equation in y. Let us see. Suppose I have an equation dy by dx plus py equal to q, where p comma q are either constants or functions of x. In that case it is called linear equation in y. Now if I have y power n extra in the right side, where n is some constant. So if I have y power n on the RHS part, then it is called Bernoulli's equation in y, where p comma q are either constants, where p comma q are either constants or functions of x only, or functions of x only. Here what I mean to say is this x is nothing but independent variable. Therefore whenever equation has like this dy by dx plus py equal to q into y power n, where p comma q are either constants or functions of x only. Of course n is some constant. Here n is some constant. In that case this is called Bernoulli's equation in y. Let me discuss one example. Suppose if I have dy by dx plus 2 by x into y equal to, for example, cos x into y cube. Now in this case my p is 2 by x, it is a function of x, and q is cos x, it is a function of x, and n is 3. Therefore this is nothing but an example of Bernoulli's equation in y. Note this. An equation of the form dy by dx plus py equal to q into y power n. Dy by dx plus py equal to q into y power n is called Bernoulli's equation in y. an equation of the form dy by dx plus py equal to q into y power n is called Bernoulli's equation in y, where p comma q are either constants or functions of x only At the place of x, you write independent variable, because in the examination, if they change variables, you don't think that always x must be there. It is independent variable, and n is some constant. Example: dy by dx plus 2 by x into y equal to cos x into y cube, p equal to 2 by x, q equal to cos x, and n equal to 3. Now our next task is to find the general solution of Bernoulli's equation in y. That we call it as method number 6. Of course, that is method number 7. Already we have seen method 5, that is linear equation in y. Method 6, linear equation in 6. And we discuss method 7 to solve Bernoulli's equation in y. So it is method 7. So it is solving Bernoulli's equation in y. Now let us write the general form of Bernoulli's equation in y. It is dy by dx plus p into y equal to q into y power n. We call it as equation 1. If I don't have this y power n on the RHS, if I don't have this term, I will get the general solution very easily. Because if I don't have this y power n on right side, means n value is 0. When n is 0, this becomes 1. Hence, it turns to linear equation in y. Now, we were discussing n is any constant other than 0. If n is 0, it is linear equation in y. If n not equal to 0, it is Bernoulli's equation in y. Now, let us try to solve this equation. What I will do is, in order to get the general solution of this equation, at first I will try to convert this equation in linear equation in y. So how to get this equation in linear equation in y? So multiply this equation both sides with y power minus n. Then I can eliminate this y power minus n. So that after doing some manipulations, this equation will be reduced to linear equation in y. Now I know how to find the general solution of linear equations in y. Right? So my intention is very clear. So multiply this equation with y power minus n both sides. This is y power minus n into dy by dx plus p into y power minus n equal to q. Now let us try to solve this. Let y power 1 minus n equal to some new variable z. Now differentiate with respect to x. This is 1 minus n into y power minus n into dy by dx equal to dz by dx. Therefore, y power minus n into this dy by dx equal to 1 by 1 minus n into dz by dx. Now, in this equation, this dy by dx is replaced by this quantity. Actually, y power minus n into dy by dx is this. So, I am replacing this expression with 1 by 1 minus n into dz by dx. I call it as equation 2. So, from equation 2 implies this is replaced by this 1 by 1 minus n into dz by dx plus p into z equal to q. Now multiply this equation with 1 minus n both sides. Therefore, this equation will be reduced to dz by dx plus p into 1 minus n into z equal to q into 1 minus n. Therefore, this equation I call it as equation 3. Now, in case of equation 3, I call it as this as P1 and this one as Q1. Here P1 is a function of x. This is constant, this is function of x. So, therefore, entire P1 is a function of x. Q is either a constant or function of x. And this is anyhow constant. Therefore, Q1 is a function of x. Therefore, this is linear in z. So, its general solution is given by z into if equal to integral q into if dx plus c. This is according to method number 5. its general solution is z into I of equal to integral q into I of dx plus c, because it is an equation which is in linear in z, because this is p1, this is q1. P1 is a function of x, q1 is function of x, hence it is a linear equation in z. Its general solution is given by this. What is my I of e power integral? Here p means p1, so e power integral p1 dx. This is e power integral, this p1 is nothing but p into 1 minus n dx. Therefore, this will be reduced to the form z is what? Y power 1 minus n. Y power 1 minus n into I of equal to, here actually this is q, but in place of q we have a notation q1, so modify this to q1. Therefore, here this q1 equal to q into 1 minus n dx into I of dx plus c. Therefore, this is nothing but the general solution of this equation 3. Now you can see, when I don't have this y power n, if I don't have this y power n, my general solution is y into I of, I will not get this 1 minus n, equal to integral q into I of dx plus c. I won't get this 1 minus n. See why we got this 1 minus n extra? Because of this y power n. So because of this y power n, y is replaced by y power 1 minus n. This p is replaced by p into 1 minus n. Q is replaced by q into 1 minus n. So therefore, when you want to solve questions in this model, you need not do entire calculation. Derivation is important for in some cases. Once or twice it has been asked in the examination. But regarding finding solution of Bernoulli's equation in y, just write the general solution of linear equation in y. What it is? Y into I of equal to integral q into I of dx plus c. But what is I of e power integral p dx? That is the general solution of linear equation in y. But I am expecting general solution of Bernoulli's equation in y. For Bernoulli's equation, I have y power n extra on the RHS. Therefore, because of that y power n extra, I will have y power 1 minus n in place of y. In place of p, I have p into 1 minus n. In place of q, I have q into 1 minus n. So because of y power n extra, 3 changes will be there in the general solution of linear equation in y. So y is replaced by y power 1 minus n. P is replaced by p into 1 minus n. Q is replaced by q into 1 minus n. That's it. That is nothing but general solution of this equation. Note these points. This is end of method 7. We were stopping session at this moment. Thank you so much. In the next session, we discuss method 8, method 9 to solve first order, first degree differential equations. That is by using Bernoulli's equation in X and total derivative method. Thank you so much.